As we wrap up this lesson on production, we've explored how to track inputs like ingredients, labor, inventory, and meal served. From edible portion pricing to yield, turnover, and food cost per meal, every concept has shown us a different angle on how to measure efficiency and performance in food service settings. But now it's time to look at the outcome, profit. Specifically, we're focusing on profit margin, a key metric that tells us how much of our sales revenue turns into actual earnings after all the costs are paid. The formula is simple. You take your net profit and divide it by your sales revenue. Then, because it's a percent, you'll multiply it by 100. That gives you your profit margin. Now, we haven't covered net profit yet, but we absolutely will in Module 9. Net profit is what's left from your profits, your revenue. It's what's left over from your revenue after subtracting out all expenses like ingredients, wages, utilities, taxes, supplies. When you subtract all of those things out from your total sales, from your revenue, you get your net profit. It's the profit that's left over. This is your real take-home value and not just what comes in on the register. So when we say profit margin, we're really asking what percentage of our revenue is profit. And we want our profit margin to be as high as possible to represent a financially healthy and efficient business. A low profit margin is not always a great sign. Let's try to work through an example. Here we have a data table that gives us a full breakdown of expenses as a restaurant is analyzing their finances. We're trying to calculate profit margin here. So this is the equation that we'll use. Pause this video. Try it on your own. The data table gives us a full breakdown of expenses. They have $57,350 in sales revenue. That's what goes on the denominator of this equation. But the cost of those sales were $33,230. They had to pay for labor. They had to pay for rent and utilities. They had to pay for taxes and for supplies. So in order to find our net profit, we need to subtract all of these things away from our revenue. So our net profit is equal to the total sales, and then we subtract out the cost of those sales, like our ingredients and our packaging, the cost of our labor, the cost of our rent and utilities, the cost of our taxes, and the cost of our supplies here. So the net profit, even though the register says that the revenue was $57,350, we really only made $6,100 of net profit here. So our profit margin is to take our net profit, $6,100, that's what goes up in the numerator, and divide it by the sales revenue, which we've already identified in the problem as $57,350. Our profit margin comes out to be 10.6%. That means for every dollar that the restaurant earns in sale, just over 10 cents becomes actual profit. It's not huge, but it's positive. And in food service industry, a consistent profit margin like this is a sign of healthy operations. Restaurants have notoriously slim profit margins, typically less than 15%. So this all checks out. Just keep in mind, when we calculate net profit, we're only subtracting ongoing operational expenses, things like food costs, labor, rent, and supplies. We're not subtracting capital costs, like buying a new oven or paying off a loan. The capital budget does not come into effect here. I know we haven't talked about budget types yet, but again, all of this is deeply tied to our Module 9 on management. If it's not part of daily operations, they don't factor in to this calculation. So when you see this 10.6%, that's telling you how lean or efficient the business is after paying its bills. Lower than expected might mean rising costs or pricing issues. Higher than average might suggest strong financial management. Either way, it's a number worth understanding. We'll wrap our production math essentials lesson with one last output concept, popularity index. Popularity index is another percent equation. This one shows us how popular a specific item is compared to everything else that's being sold. It helps us understand demand within a system. So not just how much we sold, but how sales are distributed across items. And the formula is very straightforward. You take the number of sales of an item, and then you divide it by the total sales, multiplied by 100. So example, if you sold 300 orders of chicken and 1,000 total orders across all of the dishes, then the popularity index of chicken would be 30%. Now, interestingly, you could be asked to use popularity index to forecast needs. This is a tricky situation. It would be an advanced concept on the RD exam, but you could do it because popularity index allows us to treat the menu like a system with proportions. When the system grows, the proportions will guide how that growth is allocated. So conceptually, there's two different situations you'll encounter with forecasting. In one case, the case we've already covered, you're being asked to scale a specific item, and that's straightforward. These problems won't use popularity index. If the percent is tied to a single item, then you can scale that item directly. If an item increases by a certain percent, what will the new value be? But if the percent is tied to total sales, then you're growing the entire system. And in that case, you use popularity index to determine how that growth is distributed across items. When that happens, you don't start with the item, you have to grow the system, and then you use the item share to determine its place within that larger new total. Because if all sales are expected to grow, then we have to grow the total system first, and then use the popularity index to determine how much of the total should come from each item. So to do that, you'll need to determine the popularity index and then apply that to the new total after we've applied the projections to the total sales. And please recognize that your RD exam will have hard problems, and it's okay to not get them all right. This is a great example of how we use the popularity index to forecast future demand. But anytime a data table is given in a problem, it can look overwhelming at first. So remember, take a breath, pause the video, and try working through it yourself. And then we'll walk through it together. We're told to look at seasonal lattes in November. To find the popularity index in November, we need two numbers: how many seasonal lattes are sold and how many total drinks were sold that month. From the table, you can see that in the month of November, there were 3,010 seasonal lattes sold. And to get the total number of lattes that was sold in November, we have to add up our coffee, our seasonal lattes, and our standard lattes here, which I think comes to 9,420. But let's plug into the popularity index. We'll take the number of seasonal lattes and divide it by the total number of products sold in that month, and we come up with 32%. That's a popularity index. But if you read this problem carefully, it says how many seasonal lattes are expected to be sold next November if sales are expected to grow by 20%. I hope you're starting to see why I focus so much on percent and dimensional analysis. Since we're told to expect a 20% growth next November, we need to think about percents as a metric of forecasting. So if total sales are expected to grow by 20%, and again, in November, we sold 9,420 items, then 20% more sales next November would mean 120% or 1.2, right? An increase of 20%. You could either take 0.2 and multiply it by 9,420 and add it to 9,420, or you could multiply it by 120%, which is 120% per 100, which is 1.2. Either way, the total sales next November we anticipate to be 11,304. Now, because we know the popularity index of seasonal lattes is 32% of all sales. So if we're selling 11,000 items and 32% of them are expected to be a seasonal latte, then 32%, which is 0.32, right, percent of 100, 0.32 multiplied by 11,340 will give us the number of seasonal lattes we expect to sell, which is 3,617 and change lattes for next year. So the forecast tells us we should expect to sell just over 3,600 seasonal lattes next November if trends hold and sales increase as expected. And that's a near wrap on equations for the RD exam. We'll spend more time on production metrics towards the end of the course. Remaining in Module 1, we'll cover statistics so we can better interpret dietary guidelines, and then we'll end Module 1 with enteral and parenteral calculations. Keep it up. I know you're working hard at this. I'll catch you in the next one.